Hello everyone, section 11.8, surface areas and volumes of spheres. I want to show you where the surface area formula for a sphere comes from. Surface area formula is 4 pi r squared. Pi r squared is the area of a circle, so where do these 4 circles come from that make up the surface of the sphere? The best way to show it is to look at a baseball or a softball and open up that baseball or softball. So if you open up the baseball or softball, you get these two figure 8 hourglass shape or peanut shapes. Now imagine that the wastes on these shapes get smaller and smaller and smaller. The closer that this side gets to this side, the more like a circle these become. And you can see there's a circle overlapped here, that there are 4 of them that cover the surface of the sphere. Okay, example 1. Find the surface area of each sphere. So here I'm giving you the diameter is 3, so the radius is 1.5 feet, and the surface area formula, 4 pi r squared, 4 pi, I'm going to write it as 3 over 2 squared, 4 pi 9 over 4, that's why I wrote it as 3 over 2, knowing that those were going to cancel, giving me 9 pi square feet for my final answer to part A. Part B, I'm telling you that the circumference is 15 pi meters. So if the circumference is 15 pi meters, then the diameter is equal to 15 meters, making the radius equal to 7.5 or 15 over 2 meters. Leave it as a fraction instead of doing 7 over 2 for the same reason that I had it as a fraction over here. Yeah, I got room here. Surface area equals 4 pi r squared, 4 pi 15 over 2 squared, 4 pi 225 over 4. 4's cancel again. 225 pi meters squared. That's the answer for part B. Example 2, find the diameter of the sphere. So we're going to be working backwards. I'm giving you the surface area as 144 centimeters squared. So we'll start with the formula. Surface area equals 4 pi r squared. So we're going to find the radius and then we'll convert that into the diameter. So 144 pi equals 4 pi r squared. Divide both sides by 4 pi. R squared equals 144 divided by 4. 144 divided by 4 is 36. So R is equal to 6 centimeters, making the diameter D equal to 12 centimeters. Here we have our volume formula, 4/3 pi r cubed, not r squared this time, which makes sense because volume is cubed. Find the volume of the sphere. Again, I've given you diameter, so the radius here is 3 over 2 feet. Volume equals 4/3 pi r cubed. 4/3 pi 3 over 2 cubed. 4/3 pi 27 over 8. 4 goes into 8 2 times, 3 goes into 27 9 times, and I get 9 pi over 2 feet cubed, or cubic feet. or 4.5 pi cubic feet. This time I'm telling you the surface area is 676 pi square inches or inches squared. We want to find the volume. To find the volume, we have to find the radius. To find the radius, we're going to work our way backwards. Okay, so what do I have? Plenty of them. Surface area equals 4 pi r squared over here. Volume equals 4/3 pi r cubed. All right. 676 pi equals 4 pi r squared. Divide both sides by 4 pi. So 676 divided by 4 is 169. So r squared is 169. R is equal to 13. Plug that back in over here. 4/3 pi times 13 cubed. So 13 cubed is 2,000. That's a big number. 4/3 pi times 2,197. Now I know that doesn't divide evenly by 3 because 13 doesn't divide by 3, so 13 cubed is not going to divide by 3. So times 4 gives me 8,788 pi over 3, and this is inches cubed or cubic inches. Example 4. Example 5. Find the volume of the composite solid. So this is a cylinder with 2 hemispheres on either end, making a full sphere. So I got to find the volume of the cylinder and the volume of the sphere, add them together. So let's do the volume of the cylinder. Volume of the cylinder is equal to area of the base times the height. Area of the base. So the diameter is 12, so the radius is 6. So the area of the base is 36 pi, and the height is 10. So we have 360 pi cubic inches. That's the volume of our cylinder, of the cylinder. Volume of the sphere. Volume sphere. Good. 4/3 pi r cubed. 4/3 pi 6 cubed. 4/3 pi 6 cubed. 216. Now I know 216 is going to divide by 3 because 6 divides by 3. Divided by 3 gives me 72. 4 pi times 72 times 4 gives me 288 pi inches cubed. Add these together, plus 360. So the volume of the solid is equal to 648 pi inches cubed. Example 6 has multiple parts. We're going to leave our answers in terms of pi. If the diameter is 12, the radius is 6. If the radius is 6, then 4 times 36, 4 times 36 gives us 144 pi units squared, and 6 cubed is 216. Oh, I'm going to cheat. I know it's 288. 288 pi. Alrighty, part B. If the radius is 7, then the diameter is 14. If the radius is 7, then 7 squared is 49. 49 times 4 gives us 196 pi. 7 cubed is 343, doesn't divide evenly by 3, so times 4 is 1,372 pi over 3. Here we know the volume is 3,200 pi over 3. So what's the radius? Well, 3,200 divided by 4, 3,200 divided by 4 is 800. So that's the r cubed. So cube root that. Now if you don't have a cube root button, then you can't do that. So I've got some space up here. Let me do this one. Show you what I'm doing here. Volume equals 4/3 pi r cubed. I know the volume is 3,200 pi over 3 equals 4/3 pi r cubed. So multiply both sides by 3, divide both sides by pi, divide both sides by 4, and I get r cubed is equal to 800. Okay? Well, what's the cube root of 800? Is what we want to know. Cube root. Now this you probably have not seen. So I'm going to show you something that is a preview of things to come in Algebra 2. So if you have a cube root of 800, square roots, we used to look for pairs when we did our factor tree. 8 times 100, 10, 10, 2, 5, 2, 5, 2, 4, 2, 2. With cube roots, we look for 3 of a kinds, groups of 3. 2, 2, 2. I have 3 2s, 4 2s, 5 2s. So I have one group of 3 2s. Then I have a pair of 2s and a pair of 5s left over. Those don't form triplets. So what I can do is I can pull out this one group of 2 cube root of 100. Okay. Cube root, and that's my radius. Okay, that's the r, is 2 cube root of 100, making this 4 cube root of 100, and square this. So let's go back to the 800 cube root. Again, this is a preview of things to come in Algebra 2. You will not have to do this on a quiz or a test. Squared. So now we have 800 squared cube root 640,000. Or if I do my factor tree, 800, 800, which means I now have more groups, right? Because I have 2 of these trees that I didn't have before. So I can pull out this group of 3, then this, and another group of 3 with the others. So what I have is I've got 2 to the 5th times 5 squared times another 2 to the 5th times another 5 squared. Right? So how many, this is 2 to the 10th times 5 to the 4th. How many groups of 3 do I have? I've got 3 of these. Okay, so that becomes 2 cubed comes out. How many groups of 3 5s do I have? 1. What did I have left inside? I had 2 2s left over and 1 5 left over inside. So 4 times 5 left over. So 8 times 5 is 40. Cube root of 20. So this becomes 4 thirds of this. This is my r squared. Now I have to multiply this times 4 thirds, so 40 times 4, 160 cube root of 20 over 3 for the pi. Again, you will not have to do anything that difficult. Surface area is 12 pi. What's the radius? Well, let's take a look. Again, I've got some space up here. Surface area equals 4 pi r squared. 12 pi equals 4 pi r squared. Divided by 4 pi, r squared equals 3. R is equal to the square root of 3. Diameter is equal to 2 square roots of 3. Plug this into our volume formula. And again, just to make some space, I'm going to erase here. I'm going to use this space. 4 thirds pi times square root of 3 cubed. So square root of 3 cubed is square root of 3 times square root of 3 times square root of 3. 4 thirds pi 3 square root 3's. Square root of 3 times square root of 3 is 3 with one more. So the 3's cancel. And I'm left with 4 pi square root 3. 4 pi square root 3. Okay. E and F. If I have 2r as my diameter, my radius is r, and E becomes really easy because this is going to be 4 pi r squared, and volume is 4 thirds pi r cubed. F. If the radius is 2r, then the diameter is 4r. If the radius is 2r, then the surface area is going to be r. Put this into the r squared. This becomes 4r squared times the 4 becomes 16 pi r squared. In the volume formula, I have to cube this, so this is going to become 8r cubed when I cube it, times the 4 thirds, so 8 times 4, 32 pi r cubed over 3 is the answer for part F. Example 7, we want to compare the surface areas in 6E and 6F. So what's the comparison of these? This is 4 times bigger. This is 1/4 the size. So they are in a 1:4 ratio. Example 8, we want to compare the volumes of E and F. So this is 4 thirds pi r cubed. This is 32 pi r cubed, both over 3. So this is 8 times bigger. So they are in a 1:8 ratio. Again, this makes sense because if the radii are in a 1:2 ratio, square that, you get 1:4. Cube that, you get 1:8. Okay. Example 9. The number of square centimeters in the area of a sphere is the same as the number of cubic centimeters in the volume of a sphere. Find the radius of the sphere. Okay, so what we're saying, not that the units are the same, because the units are not the same. But what we're saying is if one sphere has a volume of 4/3 pi r cubed, and that's equal to the surface area, which is 4 pi r squared. Again, the units are not the same, but the answers work out to be the same. Then we can solve this for r. Okay, we can solve this formula here for r. And what we're going to do is we're going to set it equal to 0. So we have 4/3 pi r cubed minus 4 pi r squared equals 0. We're going to solve this the correct way algebraically. There's a slightly quicker way of solving this. But I'm going to solve this the full algebra way, because you're going to be doing this in algebra 2. I'm going to factor out a 4 pi r squared. 4 pi r squared in common. What I'm left with is r over 3 minus 1 equals 0. Two things multiplied together equals 0. One of these two things has to be equal to 0. Either 4 pi r squared equals 0, or r over 3 minus 1 equals 0. If this is to solve this for r, you get r is equal to 0. And that's why the quicker way I could have done this, I could have divided everything by 4 pi r squared. It's just a little bit quicker. But in algebra, this is an answer. So technically, this is r equals 0. And in algebra, you would write double root, dr. Okay. Solve this one. We have r over 3 equals 1, adding 1 to both sides, and multiply both sides by 3. R equals 3. We don't have any units, so r equals 3 units is the answer. So if you go back, if you put a 3 in here and a 3 in here, you can get the exact same value to come out, not the same units. One will be cubed and one will be squared. Right, so that's example 6. Sorry, that was example 9. Example 10. Find the surface area of the sphere. Leave your answer in terms of pi. So I'm giving you a diameter of 18 feet, giving us a radius of 9 feet. We're going to find the surface area, equal to 4 pi r squared, 4 pi 9 squared, 81 times 4, 81 times 4, 324 pi square feet, or feet squared. Example 11. The circumference of a rubber ball is 13 centimeters. Approximate the surface area to the nearest whole number. So we have the circumference of the rubber ball is 13 centimeters. So circumference equals 2 pi r. 13 equals 2 pi r. R is equal to 13 over 2 pi. Make sure that that pi stays in the denominator and not up into the numerator by accident. This is centimeters. Okay, now we're going to go to our surface area. Surface area equals 4 pi r squared. 4 pi 13 over 2 pi squared. 4 pi 169 over 4 pi squared, don't forget that that pi is now squared. So when I reduce, 4 pi goes into 4 pi r squared, and I am left with a pi here. So my surface area is equal to 169 over pi, and this is centimeters squared. We want to approximate this to the nearest whole number. So 169 divided by, use the pi key, I get approximately 54 centimeters squared. Find the volume of the sphere. Again, we're going to leave this answer in terms of pi. So my radius is equal to 15. Volume is equal to 4/3 pi r cubed. 4/3 pi 15 cubed. 4/3 pi 15 cubed. 3,375. I know this divides evenly by 3 because 15 divides by 3. By 3. 4 pi 1,125. And multiply that times 4. 4,500 pi, and this is centimeters cubed. Example 13. The volume of a sphere is 1 cubic inch. Find the surface area to the nearest tenth. So volume equals 4/3 pi r cubed. Our volume is 1. 4/3 pi r cubed. Multiply both sides by 3/4, divide both sides by pi. I now have r cubed equals 3/4 pi. We need to cube root that. Okay, now hopefully your calculator has a cube root button. If it doesn't, then it usually has a y to the x button or a y to the 1 over x button or an x root of y button or some variations of these types of buttons. And these are the types that you're going to do your cube roots with. You should test to see how your calculator works. Different calculators work differently by doing a cube root of a known value. Cube root of 8 is 2. So you want to type in your cube root of 8, and when you get out a 2, you now know the order that your calculator types them in with. Different calculators, you're going to type that order in differently. So you want to play around with it until you know how your calculator works. I'm going to leave it as cube root of 3/4 pi for now. I'll go to the calculator at the end. So now I'm going to do, that's my r value. So my surface area equals 4 pi r squared. 4 pi cube root 3/4 pi squared. And now I'm going to go to my calculator and go 3 divided by 4, 0.75. And then I get to divide that by pi, because that pi is in the denominator. Divided by, hit my pi key. I hit enter. Now I've got to cube root that. I have a cube root key, so I know how that works. And then I've got to square that. So right now I've got 0.62035,044. It just keeps on going. So I'll write down the approximation. Approximately 4 pi 0.62035 ... just keeps going. Squared. I have a squared key here. Square that. Times 4 times pi, and to the nearest tenth, I have approximately 4.8 inches squared. This is surface area, so it's inches squared. That was 13. Problem 14. Sports equipment. The diameter of a golf ball, 1.68 inches. Approximate the surface area of the golf ball. Okay. So if the diameter is 1.68, then the radius, 1.68 divided by 2, 0.84 inches. Surface area formula, 4 pi r squared, 4 pi 0.84 squared times 4 times pi key, and I'm going to get, let's go to the 2 decimal places, the nearest hundredth, 8.87 inches squared. Do you think the value you found in part A is greater or less than the actual surface area of the golf ball? In other words, is this more or less than what the actual surface area of the golf ball is? Well, the actual golf balls get these dimples put in, and the dimples are going to add to the surface area because they're a little bit more surface because they're rounded inside than a regular sphere would be. So this is less than the surface area of the actual golf ball. So part A's answer is less than the actual surface area of a golf ball. So I don't know what the surface area of a golf ball is, but it's going to be more than 8.87 square inches. All right, example 15. A silo of a barn consists of a cylinder capped with a hemisphere as shown. Find the volume of the silo. So we have a height of the cylinder is 20 meters. The diameter of the cylinder and the hemisphere is 10 meters, giving us a radius of 5 meters. So we need to find the volume of the cylinder. It's equal to area of the base times the height. Area of the base, 25 pi. Height is 20. So 500 pi meters cubed. That's the volume of our cylinder. Volume of the sphere, times a half, because we only have half of the sphere. 4/3 pi r cubed times a half, because we only want a hemisphere. So 2/3. Half of 4 is 2. So 2/3 pi and times 25, or 50 pi over 3 meters cubed. So the volume of the silo is equal to 500 pi plus 50 pi over 3 meters cubed. And let's get a common denominator, so 1500 pi plus 50 pi over 3 meters cubed, or 1550 pi over 3 meters cubed. And let's round this one. So 1550 divided by 3 times pi key gives us approximately 1623.2 cubic meters, or meters cubed. Example 16. 4 metal balls fit snugly inside of a cylindrical can. So in other words, the diameter of the can and the diameter of the metal balls is exactly the same. A geometry student claims that 2 extra balls of the same size can fit into the can, provided that all 6 balls were melted down and the molten liquid poured into the can. Is the student correct? So let's do this. We are given a hint, let radius be r. Okay, so if the radius is r, then what's the height of the cylinder? Height of the cylinder is 2, 4, 6, 8 r. The height of our cylinder. So now we can find the volume of the cylinder, and we can subtract from it the volume of the spherical balls and see how they compare to each other. Volume of the cylinder first, equal to area of the base times the height. Area of the base is pi r squared, and the height is 8r. So we end up with 8 pi r cubed for the volume of our cylinder. Let's find the volume of one of the metal balls. So volume of the sphere is equal to 4/3 pi r cubed. But we have 1, 2, 3, 4 of them. So we have 16 pi r cubed over 3. Subtract these to find how much airspace is left inside. So we have 8 pi r cubed minus 16 pi r cubed over 3. Common denominator, we need a 3, so this is going to be 24 pi r cubed minus 16 pi r cubed over 3. 24 minus 16 is 8. 8 pi r cubed over 3. And this is exactly equal to 2 of the balls, of the metal balls. So is the student correct? Yes. The geometry student is correct. All right, 17. History. The sphere fits snugly inside of the cylinder. So now, again, the radius of this sphere is the radius of the cylinder. The height of the cylinder is equal to the diameter of the sphere. Archimedes, so around 287 to 212 BCE, asked that such a figure be put onto his gravestone along with the ratio of their volumes, a finding that he regarded to be his greatest. What is the ratio? Well, let's take a look. What is the volume of the cylinder? So volume of the cylinder is area of the base times the height, area of the base, pi r squared, height 2r, giving us 2 pi r cubed. What's the volume of the cylinder? Volume of the sphere is equal to 4/3 pi r cubed. We want to compare these to each other. What's the ratio of one to the other? So 2 pi r cubed compared to 4/3 pi r cubed. Okay. I'm going to multiply both sides by 3. Divide the pi, divide the r cubed from both sides. So I'm going to have 6:4 or a 3:2 ratio. And that is, so the volume of the cylinder is in a 3:2 ratio to the volume of the sphere. Okay? And that is what Archimedes regarded as his greatest discovery. That's the end. Thank you very much. Bye.